Good morning, everyone, and thank you for joining us today for another session of Indian webinar series, Introduction to Computational Drug Design. It's co-organized by Schrodinger and PCI. I'm Shelvia, and I'll be your host today. I'd like to take a moment to thank our collaborators for supporting this event and the JSS IET team for hosting these sessions. Today we have another demo session on pharmacophore modeling and screening large compound libraries by Dr. Vinod. Uh, so as the other session, there'll be a demonstration today followed by Q&A, and after that there'll be a quick announcements during the course of this presentation. If you have any questions, please feel free to drop them into the query into the chat section of the YouTube link, and we will add them in the Q&A session later. Without further ado, I'd like to introduce our first speaker, Dr. Vinod.
Sylvia, very thank you. Very good morning to everyone. And please confirm if I'm audible. Is my voice clear?
Yes.
I will share my screen. Hold on. Hope you can see my screen.
Yes, I can.
I have placed it in presentation mode. Today's topic is ligand-based drug discovery, where I will be particularly discussing on pharmacophore modeling and how to use it for screening and how to perform validation using those pharmacophore generated. So, so to get started with, it's very critical that we clearly understand what this pharmacophore is. As per IUPAC definitions, you can see, but a very basic explanation is that minimal chemical features required to evoke a biological response. So now when you say minimal features, because a molecule may have multiple features, so our objective is to identify minimal critical features that can evoke a positive or negative biological response, whatever your interest may be. So as per pharmacophore modeling is concerned, it falls in, as you can see, purely ligand-based drug discovery. And I will be showing you how to generate pharmacophore using receptors also. So that is the reason I am including both quadrant, that is quadrant 1 and quadrant 2 also, where we will utilize the structural information. And basically it consists of critical steps where we use the database which is screened against this pharmacophore identified to find out new promising molecules. Now, see, there are four possibilities in any research. You may have a situation where you have multiple ligands that can be congeneric series, or it can be diverse molecules, or you may have single molecule which seems to be active, or else if you have an apoprotein. And the fourth scenario is if it is protein ligand complex. In Schrodinger, it's very easy to perform all these tasks. So don't think these are four different panels. This is a single panel where the drop downs only changes. So I think very soon, like I'll show you like how it is. Remember, all these four panels are same. Okay. So now, and one more important criteria that we need to understand is there are two kinds of excluded volume. So one excluded volume is receptor based excluded volume. And the next one is active inactive, means the inactive space of the ligand is also called as excluded volume. Okay, when we align as per the molecules and all that. So this is how it looks in the pharmacophore. Like if you see the interface, and I'll show you. And by using enrichment calculation, we will perform the validation. So that will be our objective behind performing all this. And let me just quickly go into demo. Okay, so we have the master here. The first important thing that you need to perform is click on File, Change Working Directory. Now, if I do, you can select the directory of your choice. Many students make this mistake and they get confused where their files are. So it is my humble request, please change your directory to the directory of choice. And today we will be working on different scenarios. Like for example, if I try to sketch a molecule of choice by 3D sketching, so this is a very random molecule. Okay, I'm just adding whatever I need. So I added this. Okay, very random molecule, and this I'm directly sketching it now. Okay, imagine you have this molecule, and let me minimize it. A basic minimization, which you can do by using macro model minimization. Imagine this is your competitor molecule which has been found active. So I'm running by default options. So any structures that either you sketch in 3D or 2D, it is necessary that they get prepared well. So this is the first case scenario where I have only one active ligand. When you have that situation of one active ligand, you need to go to task, browse, and I need to know which features would be critical for this. So what you have to do is you have to say develop pharmacophore. Can you see it has identified all the possible pharmacophoric features? So it contains now 4 acceptors. You can see 1, 2, 3, and 4, and 5, and 6. So these are the 6 features pharmacophore. The drawback with this is like it does not know, if we only know it is active and nothing else to compare. So only way to identify the best pharmacophore is do perturbation and combination, like generate a 4 or 5 point hypothesis, a 6 point hypothesis, and then start validating. For example, if I want to go for 4 point hypothesis, so I have now 4 point hypothesis. Hypothesis is nothing but the imaginary points which are specifically designed to stay at particular distance and angle. So that is here. Now you can see this is one molecule. So this is a very random molecule. I have created it. Now what I can do, I can perform enrichment calculation if you have already other set of active molecules, uh, or else you have to perform the same task in perturbation and combination, like combining them. So this is for single molecule with or without biological activity. If you know qualitatively or quantitatively the biological outcome, this is how you can perform your screening. But it's highly unreliable because I'm not able to differentiate between active and inactive features, right? So that is the reason the benefit is always performing with multiple set of molecules. Now let me show you. So I have a series of molecules. You can see this is a series of molecules, and the only thing that you need to do is just change this to multiple ligand. So currently it has 36 molecules as actives, means it has considered all molecules as actives. Now, activity is a privilege. You can't give to all the molecules. It can be given to only top 5 or 10 percentage or in between. But don't try to put your actives as full molecules. You will end up in a pharmacophore which is not able to differentiate between active and inactive. So for that, let me show you the data first. In the project table, you can see all the data molecules, and all are these are conjugate series of molecules. So you could see here, like all the molecules are there, and its biological activity can specifically be viewed by this property tree. which I can activate and deactivate as per my choice. So this is added by user. You can see the activities defined. I have highlighted the thing like you need to convert any ligand-based drug discovery technique. You need to convert the molecule, the biological outcome into PIC50 value or KI into PKI value and all those things. So all these values are already converted. In case if you're planning to add property, go to data, add property, and by type, you can give it to real and then activity. This is just a way to add the activity if you're planning to add it on your own. So usually many of you will download the files from our binding DB. So you will already have the activity and you need to convert that into PIC50 or PKI value. I already told that formula. So nothing else, you have to add the constant like 9, then go for minus, then you have to go for function log to the base 10 and add a activity column. Like in the property, you can see here act is there. So it doesn't have any value, so it will not show anything. But this is how you need to add values for conversion. You don't have to go anywhere else. So the molecule activities are already converted. Now you can sort it. Like okay, you will notice the highest and the least is around more than 3 logarithmic scale. Diversity is there. Okay, Pharmacophore does not. It's not required to have, like it's not compulsory to have congeneric series of molecules. But in QSR, it is critical that you need to have congeneric series of molecules. So imagine I have a problem in hand. The
Hi,
problem is
Vinod.
identified.
Vinod,
Yeah.
sorry to cut you. We have a comment asking you to go a bit slowly.
Okay, fine.
Okay, thank you, Vinod.
Yeah. So if you notice, I have just browsed the files and the sessions are recorded. So I have not done anything hi-fi here. I've just imported and I'm just explaining. So please, it's my request. Okay. So I'll try to go a little slow then. Okay. Yeah. Thank you. You can see here that the molecules are available. And I already showed you the molecule for the hypothesis for single molecule, right? And now my task is to identify a common pharmacophore that is common for all these molecules. Okay, so how you can do that is first you need to define the actives and inactives. So you have to hit on activity. So it will browse the active activity column. Okay. And you will notice that you have to define, I told you top 5%, or you can see active if greater than 7. This is a random number, means considering my top 5%. Okay. And less than or equal to 5. Means any molecule that is higher than 7 will be considered as most active and less than 5 is less active. Okay, if you click apply and if you say okay, then your job is done. Okay, now you have defined the actives and inactives as two separate set, right? See, total data set had around 36 molecules and you are defining only 7 as actives and 7 as inactives. Now what it does is like, I'll just place this run, but before that, I'll show you another capability because I've already generated the conformer for this. So I will take that and use it. And in the meantime, let me just import the conformer. So if you see this one, it has all the conformers of this 36 molecule. If you notice, this is around 457 entry with conformers. Now, but if you notice here, it has identified only 36 molecules. Again, only I have to do is I have to just define the activity. So this is just to save our time, and we'll see like how quickly we get the outcome. Is it okay? So you can by default, you are always like requested to run it, but this case, I'm not generating the conformers. The hypothesis setting, you can see, let it be by default. I'm not changing here. The only thing which I want to include is create excluded volume shell. Okay, so which will consider the inactives. It will try to identify the inactive regions, and you can add actives and inactives too. So I will hit save, and now I am all done for launching my job. So the only options what I did is I have selected multiple ligands and defined the actives and inactives, and then mentioned for having an excluded volume. Now what I will do, I will set it up so that it runs quicker. You can see there are 8 processor. I have close to 12 processor machine. I'm taking 8 processor and I will hit run. Okay, let me give a new name. So I have hit run now. So the job is launched. I think, let me reiterate. The point is, I have generated the pharmacophore for single ligand, and now I have launched the job for multiple ligands, where I just chose to run it from the conformers of my interest. But you can also run by using set of your own molecules. Okay. And in case if you don't know the activity, then you can define the actives and inactives as per your own choice. Like this activity won't come, but you have to manually define whether it is active, inactive, or none. It's up to you. You need to define it, okay, as per the literature. Now I will go to the next stage, which is to generate the pharmacophore of protein-ligand complex. So I have a, a complex which is fully prepared. So you can see it's a complex. It has a ligand molecule in it. And you will notice the interactions. Okay, now I'm interested in knowing which are those critical features that will assist in my binding. So it does not require any biological activity and all that. The pharmacophores will be scored as per the energetics of the features. And the same panel will be helpful in identifying the correct features. Like you can see here, receptor ligand complex. So it automatically generates it identifies the bound molecule. It is requested that don't generate the E pharmacophore. This is the concept of E pharmacophore using dogged complexes. It's a crystal structure. Crystal bound conformations are much better to use. It is always preferred to do on the experimental structures, not your own dogged molecules. If you're planning to do that, it's critical that you stabilize that by using molecular dynamics and take the stabilized pose for your E pharmacophore. So that is the best thing to do for better accuracy. Now, this is for my receptor 3LAU. So this also I can generate. And you can see the options for excluded volume is by default set. Nothing else. You just have to hit create. So the jobs are running now. You could see that there are multiple jobs that I have launched. One is pharmacophore using multiple ligands, and the other one is pharmacophore of a receptor. The third one means the fourth one is now if you have a apoprotein, a protein that does not have any ligand in it. So imagine I have this protein which does not have any ligand in it. So how to generate a pharmacophore for this? The first thing that you need to do is you have to generate the binding site analysis. So that you can define the binding pocket properly. Now for that you have to run site map, which is there in the other application. So what I will do, I will just hit apoprotein, sitemap apo and run. I'm just explaining various aspects of drug discovery problem. It's not straightforward as it looks because different researchers face different problems. Okay, so I have generated the binding site details here. You could see the binding site details are available, and the residue ASL for the binding pocket will be found in the sitemap tab. I'm just opening the project table, and in project table we have tree where you can see that sitemap has the residue ASL properties. Can you see here? So this gives you the definition of the binding site. So your active residue may be part of that binding site. So now you can judge which site is better based upon the D score. Site score and D score. If D score is more than 1, then obviously that is druggable for organic molecules. I'll copy this ASL details. ASL is atom selection. I'll copy this and I will take the receptor, and you have to go to task, browse, and develop pharmacophore hypothesis, where this time you need to use the option receptor cavity. And here I will specify residue. Select, and you can paste that ASL from the sitemap. So I've done that. Now it has identified the binding site, and it will give you the set of features for your binding site. Can you see here? And that you can set it up. It is complementary to the residues that are available in the binding site. You can cross check with your active site residues and select those features of your interest. You can increase it, decrease it as per your choice, and the features will increase. So I'm just selecting now 4 features, and I can create a hypothesis from a apoprotein. I think we just noticed how we can run and generate different pharmacophores at different scenarios, right? Just to recap, here you have the single ligand, and this is a pharmacophore generated for a single molecule. And then I took set of 36 molecule and generated the pharmacophore. I got multiple outcomes. Here, can you see? There are so many different pharmacophores. Because I have the flexibility, I gave the flexibility of actives and inactives. And I'll tell you now how to validate a pharmacophore. So this is the inactive region, excluded volume. Now what you need to do? What you need to do is, please let me define. I am interested in knowing a pharmacophore that will match with actives. Shall we check? First, we will check qualitatively and then we will assess quantitatively. So what you need to do is you need to include all the active molecules that you use for your pharmacophore generation. If you visualize this, you can clearly see that the molecules are very nicely aligned, right? It has thresholds. So for example, this is the feature tolerance. You can remove, you can see this. This is very nicely excluded. Means all the molecules are properly aligned. Now, if the same thing, if I try to align with inactive molecules, it should not align, right? So I'm just trying to align them now. And if I activate the threshold, the tolerance, you can see tentatively the inactive molecules also get aligned. Now, how do I know which pharmacophore to select? Now, for that, what you need to do is you need to check with the values, the fitness scores. So for that, I need to activate all the properties for phase because phase has generated this. The critical value for scorings are site score based upon the site overlap, then vector overlap against the active molecules and inactive molecules, and the volume overlapping. Now, if your pharmacophore is matching well, you get a max score of 1. If it is not matching well, then you get less scores. Now, obviously, we already saw, and the summation of all this score is something called as fitness score. Can you see here? This is the fitness score, and it also consists of the number of sites matched. Now, according to that, you would see that the actives are very closely matching, has a very good fitness, but inactive is also not performing. It's very close to your active. This means that the pharmacophore is not able to differentiate the actives from inactive. It is very well suited with the active molecules, but it's a bad signal that it is nicely aligned with your inactive molecules also. Okay, so now what will happen is, now you need to select this and I will open all of them. We need to search for those set of molecule where the pharmacophore is not matching well with inactive molecules and matching well with active molecules, whatever is possible. So I'll expand this group. Now see here, now you will notice, see, if anything is less than 2, 2 is also high. See this one you can notice here, these are of less values. Whereas, see this H, that is hydrophobic, ring aromatic, and ring aromatic seems interesting. So this feature looks interesting. Where the fitness score is less for most of the molecules, for the inactive molecules, and very nice for the active molecules. It will identify the reference molecule by this check mark, where the maximum score is 3 and the minimum score is 0. So now this pharmacophore looks promising and you can do screening from this. So whatever pharmacophore I have generated, I can validate by using enrichment calculation. The enrichment calculation options are available here. You can see validate hypothesis. THHRR, then you have to hit H and then next step and validate hypothesis. So this panel comes where it is loaded and you need to browse the set of active molecules and you have to browse the decoy set. So decoy set are set of fragments that are not biologically active but used for checking the enrichment to confirm statistically whether they are is it molecules came by chance or easily they may be really promising. So this decoy set of molecules are also available in Schrodinger website. So one I am just using it now and nothing else. You have to hit run. So this is a validation which you can perform. In case if you are interested in selecting multiple pharmacophores for validation, nothing else, what you need to do is you need to select all the entries of your hypothesis. Now I'm just going to select see everything, whatever the pharmacophore I have generated, I'll select everything. Okay, so I have selected now whole entries and this validation option, let me just select the whole entries. And if you hit here, you can see. Now I can add all the pharmacophores that are available in the project table. Can you see now at one go, you have selected multiple pharmacophores for validation. Now, what you need to do is once this calculation is done, we have enrichment viewer. So here it is, enrichment viewer, where you can browse the output. Like for example, this is just for one hypothesis, but you can also do for multiple hypotheses. Let me browse that. Yeah, so here is a collection of hypotheses. Can you see here? So at one go, it performs the complete enrichment calculation for all the hypotheses that you have selected. So it is going to give you details in the bottom right side. Can you see here? This is the enrichment report.
Hi, Dr. Miller. Sorry for disturbing. I think some of the attendees are thinking it's too fast. So if you just slow down a little.
Okay. More slow.
I think because I think you clicked like a lot of things too fast.
Okay.
Alright.
So I will just tell you clearly. Okay, let me just redefine the whole case study. I have nothing but I have just identified different pharmacophores. And please, viewers, note that this is recorded. So you can play it as per your own pace. But the point is, I have taken now the pharmacophores, okay, the various pharmacophores of your interest, and I have done enrichment viewer. I have selected, I have run this right. So once you do that by enrichment viewer, like for example, if I take this, I'll keep it as simple as that. You get the enrichment factor, like how well the pharmacophore at 1% has done the enrichment calculation and perform the bedrock and the number of matches and excluded volumes. The other statistical parameters are ROC. ROC is nothing but receiver operator characteristics area under the curve, and bedrock is nothing but Boltzmann enhanced discrimination receiver operator characteristics. So these are all statistical terms, and AUAC is nothing but area under accumulation curve. What simple methodology you can understand is the enrichment, it is in percentage. So higher number indicates better, means 100% is the max, and bedrock scores varies from 0 to 1. Okay, whereas ROC also varies from 0 to 1. So for a better value, you need to be close to 1. So that indicates that your pharmacophore is best to use. Is it fine? So like this, you can validate your various pharmacophores. In the meantime, let me just show you the pharmacophore which I generated using protein ligand complex. So here is the pharmacophore which I generated using protein ligand complex. For the viewers who are feeling really discomfort, let me tell you, I have not used anything hi-fi here. This is a single panel which has multiple options for generating the pharmacophore. Step one to generate different pharmacophores. Step two is to validate that. So whatever pharmacophore that you identify, you can click and say validate hypothesis. And there you have to browse your actives and inactives. Okay, so now once you have done that, if you identify the best pharmacophore, the next thing that you need to do is add to database screen. Okay, just say 3 steps. I was explaining a lot. It may look like so many informations because I'm trying to explain 4 scenarios at one go. Sorry for that. But here you can notice you have to mention the phase database. Phase database that is already been prepared, and you can use project table also if you have any file of your interest, right? But now I will use phase database. What I have to do is add, browse, go to my computer. I have a database that I have prepared already. So phase 3D QSR is nothing but endo. That is a database that is being created in advance to be used. Let me just show you. Yeah. So here is a small database. It's a very small data set. And then if you run, then you can see it will screen the molecules and it will give you the output. And all this calculation I have run on the go, right? I have not imported any structures or anything that is required. So that just to summarize, let me just tell you very clearly, like I have done this develop pharmacophore. Okay, point number one. Then I have performed enrichment calculations here. And the third one is screening. Like, like I got the results. Like if you see H, hypothesis, next step, add to database screen. So these are the 3 steps for pharmacophore in between all our validation steps. And here you get the hits that been identified. So here is your pharmacophore, and you can see all the molecules that has been found. So you can include all the molecules. You can see this many molecules has come in. Okay, so this is your pharmacophore, and these are your various hits that has been identified. And this molecule, whichever has synthetic feasibility, can be tested for further studies. So sorry, I'm really sorry. Maybe next time I'll try to go a little more slow, but please don't get confused. I just showed you 3 panels only. So that's what I have planned for today. So if any questions, you can ask me. Yeah, it means you can sort the molecule based upon the fitness score, like whichever has higher fitness can be selected from here. Okay, Sylvia, thank you.
Thank you for the presentation. We have received a couple of questions. The first one is from where did you download those 36 molecules?
I think this was covered in the presentation. So let me just, I hope my screen is still shared, right?
Yes.
So you can get molecules from Binding DB. I think Prajwal also explained it specifically. Binding DB. Okay, so here you get a repository of all the receptor of your choice. You need to identify, you have to give your target choice, and then you can download, or you can sketch your own molecule of your choice also. You can sketch using Mastro.
Right. And how do you create database for screening?
Okay, it's very easy. Database creation is actually, imagine like you have series of molecules. It is an upgraded version of lick prep you can consider. And thanks for pointing it out. I missed it. So here is an option for creating database where it will be pre-prepared with, you can see, skip duplicates, browse the molecules. It will perform the ligand preparation, and it also can handle the leak filtering. So this database doesn't require any ligand preparation, and it will be quick for you to run the calculation against this, especially virtual screening or pharmacophoric screening. Is it fine?
Yes, thank you for those answers. I think that's all we have for now. As a reminder to all of you, if you have any questions, you can get them added, and we'll help answer those. You can also email them to us at ddcourse@schrodinger.com. If there are no more questions, I'll quickly take the announcements. One second. So yes, I hope you can see my screen. So a few things that I want to point out again is that we have a Glenmark presentation coming up this Friday. It's only live, so make sure you attend the live session. There won't be any recordings available on the YouTube channel later. It's 10 a.m. on Friday. The other thing is SOC. The deadline is reaching quite close. So make sure that you register and pay um, before October 26th. That's the only SOC session that we have this year. There are no more sessions in 2020. The next will be in 2021, and the discount code that we have given to you cannot be used after this session. So make sure if you're interested in SOC, please register. The other thing is every Thursday we have office hours. So if you have any general questions, or if you've received the evaluation license and you've been working on it, and if you have any doubts or technical queries, you can join us every Thursday via Zoom. The link is there on our website page for this course, which is schrodinger.com/dd course. So you can go there and find the Zoom link. So every Thursday from 4:30 p.m. to 5:30 p.m. We have office hours, so you can join with the same link every Thursday. The link doesn't change; it's the same link. I think a lot of you have already received the evaluation license and you're already working on them. If you haven't received them, probably you would have received an email from us. If you haven't received an email from us, there could be certain reasons for that. If you have not mentioned your guide details, if you are from from academia and you haven't mentioned any of your guide detail, that could be one of the reasons that you haven't received the email from us. So please make sure to fill in all the details, because we cannot offer you evaluation unless we have all these details. So as I said before, you can email us at ddcourse@schrodinger.com if you are facing difficulty in any of these things. um, I think that is it. If you haven't filled the evaluation form, please do so. If you haven't received the link, please write to us and we'll send it to you. I think um, I have received a few questions here. I'll just read them out. So, if you go to the question is, I hope all the demo topics will be covered in the online course. The online course has a separate syllabus, so you can go to the online course page, which is here. It's schrodinger.com/schrodinger hyphen online hyphen learning. You can go there and look at all the syllabus, whatever is covered in that. It is a separate course. It has nothing to do with this course. There's no overlap, or this course is not designed as per the other course, or the other course is not designed as per this course. They have total different sort of pace, and how the syllabus is, how the modules are. So you can maybe, if you're interested, just quickly go to that page and look at it. What is the syllabus, what all is covered, how the modules are, everything is there. um okay, the next question is, um if you already are using DDH 2020, your probably the license will be valid till October 15th. um so DDH license only been given to you in order to participate in DDH. um and You can obviously get evaluation again from us for the PCI event. You have to just fill in the form, the evaluation request form, and yes, we will give you the license for that. um okay, so now some of the questions are for about the presentation. So there's a question: can you create a cheat sheet on how to do pharmacophore modeling? Hello, Dr. Vinod, are you there?
This recording is already available in the YouTube, so they can go through. They'll get the idea.
Yeah, so all these recordings, except the one by the industry speakers, only those will not be available live recorded. Everything else is recorded. Also, um, we showed you how to get the tutorials with the help button on top. When you have the Maestro open, you can go look at the tutorials. There are user manuals. So all that you need is there. Um, is that all?
Yeah, thank you,
Okay,
Shalya. Thank you
sure.
all.
Thank you. The other question is, I don't know what it means. The pop-up menus are very light. Could not understand exactly what you were doing. Again, it's all recorded, so
Yeah,
you could go back and pause it
just
where
pause
you're
it.
not. Yeah, just like, go through it at your own pace.
There
Um,
are settings, speed settings to play also.
yeah,
As
yeah. So as we said, it's all recorded. Yeah. So I think that's all for my side. There are no more announcements. If you have any questions related to anything about this course, you can write to us on ddcourse@schrodinger.com. And even if you have technical questions, you can write to us on that email. Other than that, if you have specific questions to ask our scientists or our technical team, you can come for our office hours, which are every Thursday, 4:30 p.m. to 5:30 p.m. It's via Zoom. The Zoom link is already, I mentioned, it is there on the website. That's all from my end. Thank you for joining us today, and thank you for submitting your questions. Have a great day. We'll see you tomorrow. Bye bye.